Thank you very much, Stefan. Good. Wonderful. Yeah. So everything is set up. I think I'm sharing broadcasting. Good. Yeah. You see, this is not my suggestion for a user interface, how it should look like. I want you to watch me first. I will not present you any ready thing today. I'm here just to present you ideas. And we are in the process of redesigning Equilib in a way, because we think it can be made easier today. It should be made easier today to perform equilibrium calculations, especially for new users. I always love teaching, and whenever I'm teaching, I see that if you have to tell a user, you have to right-click here, and then you have to go there, and there's the context menu down there. It's not ideal, and I think it can be made easier. Also, if you're doing really complicated things, if you want to make an overlay of two different plots, that means you have to calculate one, save results, calculate the next one, plot this one, then perform the overlay. And I think that that's something we can do better. In terms of company strategy, in a way, I would like to point out that when we started the Curve Optimizer development in 2022, 5 years ago, one of the aspects was that we, personally, we didn't have a lot of graphical user interface designers at GTT, as you can imagine. Yeah, we're all material science engineers. So we had a lot of respect of designing a graphical user interface that is nice to use. And we thought, with Curve Optimizer, we will not do you, our main customer base, any harm if we mess it up. Because we had to learn. I think we haven't messed it up, but still we have learned a lot, and we want to now transfer what we have learned to Equilib. Good. So now let me move this. And what you see here is I'm sorry, it's not that large here. Probably better for the online audience. So I have to zoom in once more. What you see here is one suggestion, and let me guide you through this. Yeah? One point that Jean-Philippe mentioned earlier was we're doing an NPT calculation. NPT, I think, is a very strong keyword, because this is what most of our calculations are. We fix composition, we fix pressure, we fix temperature, right? Okay, and that was, we have played with a number of different setups how to allow the entry point. What is our entry point for an equilibrium calculation? And we figured out that actually this is a very nice entry point, the NPT idea. That's something that Bruno came up with after a while. After we failed with ideas that I came up with. This was something that he has done. The idea of allowing here a couple of options. So the single point calculation, the NPT calculation on the one hand, and if you choose this one, you are provided with a user interface that is easy to use. You have a composition input. In there you can define several materials. Let me just collapse this. And then you have to define temperature and pressure, and that's it, right? Then you press calculate and you go. Another idea would be a sweep. Yeah? So you don't only want to have one temperature, only one composition, but you might want to do a temperature sweep calculation. And as you do this, you click on it, let me collapse the material again, and you see immediately here the syntax that we're proposing. You type T, I mean, it's already in here, T. And then you see there's a new box here, which is the variables. And in the variables, you can set min and max of the temperature, for example. And you can use then a number of steps. You can use step size, or maybe even an automatic sampling mode that we will implement in the future. We have started that already, looking into it. Good. And then just coming to the composition sweep, you go to the composition sweep and you directly see what is the syntax you have to follow if you want to put in a variable composition. Now I want to quickly talk a bit about that material box here. So we have the composition as the highest hierarchy, but then we as materials engineers, metallurgists, we are thinking in terms of materials, not in terms of composition usually. And if we think about materials, our main connection is always the composition, even though there is all of the 3n degrees of freedom concerning structure, but we don't care about that in the input. Yeah, in the input it is composition only. We only need to define that. Okay. Okay, so we probably want to be able to define several species here, make it an whatever, some alloy, you can see it here. Yeah? And you see that we have here now introduced a carbon concentration X, and we have we're suggesting somewhere this the option to balance then this explicitly via changing the iron concentration here. So there's all in percentage, you see there's all in relative amounts. We can also remove the relative amount switch here, and then we're in absolute amounts again, and now you see that we have a fixed iron concentration, we have still the variable carbon concentration. It is a different sweeping axis that we're following here, because we're not compensating for addition of carbon by removal of iron. Yeah? So it should be easy to define your composition variables to go through chemical space. Okay, this is just for one material. Of course, we want to be able to also say that we add a second material, just for the sake of the argument. For example, we could add oxygen here. We understood the syntax already. We can define variables. So I will just call this y. But maybe y is not nice if I later plot something. So let me give it a different variable name. I would call it oxygen amount in mole. Also note what we think about flexibility in terms of units. Very often you have units in mole, maybe, especially for a gas. You would want to define a gas composition in mole, but then maybe you want to define the overall mass of the system in grams again, also including the gas phase, and this is why we suggest to decouple mole and gram input amount for material streams a bit. Okay, I think that is, okay. And now, because I wrote oxygen amount, there's a new variable that was defined on the fly, and that's available here. So I've also now changed and extended from the rudimentary 1D composition sweep to a 2D composition sweep, because now we have two composition variables. Yeah? And that should be kind of easy to do. Maybe we are saying we actually don't want this carbon concentration to be an actual sweep calculation, but we want this to be our target variable, and then we want to define that this should be a liquidus. I'm just making up something here. A liquidus target. Yeah. So we are changing. We are allowing Equilib to change the carbon concentration so that we are on the liquidus while also sweeping over the oxygen concentration. Yeah? So this should allow us quite a bit of flexibility as you're used to from Equilib at the moment, but with a cleaner user interface. Maybe we don't want to do this one, but maybe we just want to do two different calculations. Yeah? So we say number of steps, now we make it 2. And this is something that it should be possible to do. Then you say run calculation, and it should be possible then to, you see there's nothing really happening here. There's a counter that's counting. There's no actual calculation attached here. We're still in the user experience design phase. We're starting the implementation now. But then the idea is that it should be easy to create diagrams that contain already the overlay information, because we've run both calculation at once, all of the data is there, and then we just can define the diagram like that. Okay, now once we have that, I want to quickly go to one special part that I think will be important. We will provide you with presets, and I think they will make it easy to get started. They will make it easy to understand the concept of the user program. But I think it's also important that you're able to build on top of that and define your own presets. Maybe one of the calculations that you're doing very often is the calculation of a slag metal equilibrium. So I've set this up here just to demonstrate the idea. If I have defined this already, I have defined a slag metal equilibrium recipe in a way. And in here, I have a slag composition that I specified. I have a hot metal composition that I specified. You see that I put 100 tons for both of them, both are in weight percent also. And if I now want to do the calculation on top of that, it should be easy to simply say, okay, now this should be 25 plus X for the CaO concentration, and the silica is automatically balanced then based on that. Yeah? While setting these predefined calculation inputs, we also want to save already predefined results. So what are the results that you care about when you use this one, the slag metal equilibrium? Maybe you see that also when I load this, there is something already popping up here on the right-hand side on the output side, because you know that you usually always look into this number, this one number from the output, the amount of carbon in liquid. Yeah? So it's already specified there that this will be automatically displayed in the output results. You don't need to look at all output results, right? I mean, you usually don't care about 95% of the information that is in an Equilib results page. Yeah, you only care about a few points of information, and this filter is what you define here. Okay, I want to quickly come to the point when Jean-Philippe presented, he said, yeah, and then there is the initial conditions tick box that you only need if you actually want to calculate a heat balance. And I think that is easy for Jean-Philippe and me to understand, but maybe not for all customers. Always, what's really the difference? The difference that we see is that in equilibrium calculations, you define the system composition, you don't care about the reactants. In a reaction calculation, a real reaction calculation, when you define the reactants, that means you're interested in a reaction calculation. And this is why we will move this into the reaction mode. And if you go to the reaction mode, and you see there are a couple of presets now, also new presets concerning the single point calculations. Maybe you don't want to do an isothermal calculation, but you want to do an adiabatic calculation. And if you, let me just collapse the reactants here. If you do this, automatically you get as an input field the enthalpy, and not so the enthalpy of reaction, not the temperature. And then the temperature is calculated based on that. Okay. Concerning the reactants input, if you care about reaction properties like the enthalpy of reaction and all of that, then you have to specify a bit of extra information concerning your reactants compared to just the system composition, right? You now have to say my reactants consist of this phase and that end member, yeah? Or you have to say my reactant consists of this composition in equilibrium. Yeah, and these are things that we have drafted here, how to do this. So in this case, this is an initial conditions block where I can say, okay, I have an iron carbon stream here that has a starting temperature of 2000 degrees Celsius. Yeah. You could also select that you want to assume that this one is not any of these phases, but should only be the liquid phase. Okay, yeah, so now we have constrained the input stream. Already it will be equilibrated, but it will only be equilibrated using the liquid phase model. Okay, and also here I have set up a single cell BOF model, where you can see hot metal composition here, oxygen with oxygen amount as a variable here, scrap that's input also, and then lime that's added, and I don't know, I vary here the oxygen amount. Yeah, so it should be rather easy to perform such calculations. One of the presets I was playing with was for Alex, who's not here. The 20% liquid calculation, also something that's I tested last night and can be set up already with the ideas we thought about so far. So I'm presenting this mainly as an invitation for you to reach out to us if you say this is a calculation that you can do maybe with a little bit of work in Equilib today, and you would love us to think about how we can make it easier to calculate this, how we can make it easier to visualize the output and all of that. We are looking for challenging but really interesting cases so that we can consider this while actually now in the next step building the user interface, and then next year I think we will present this live in action at the users meeting. Thank you.